Now that we've learned a little bit about cross sections, we want to be able to first form the three-dimensional solid and then find a cross section from that solid. So here we have a red triangle with vertices at 2, 0, at 8, 0, and at 2, 6. And we want to be able to revolve this around the line x equals 2 and then find a vertical cross section of that three-dimensional solid that's formed. So in order to do that on this, I want to find where x is equal to 2. And that's going to be this line right here. X equals 2 is this vertical line here. And we are going to be spinning this around to form a three-dimensional object around that line. Now, drawing that out isn't necessarily going to be the easiest thing to do, so I'm going to go to one of the resources that I gave you guys so that we can visualize what is happening there. So here I can put in a new polygon. I can click new polygon down here. We want 3 vertices because it's a triangle. I'm going to put in those coordinates for the corners. So one of them was x is 2, y is 0. One of them, x was 8, y is 0. And the third one, x was 2, y was 6. And then I'm going to hit graph, and it's going to give me that triangle that we had back here in red. But now I can do some stuff with that. So we wanted to be able to revolve around the line x is equal to 2. So if I scroll down to the bottom here and select across x equals, I'm going to get rid of the 0 here, put in a 2, and just make sure that that circle is filled in next to that. I'm going to come up and hit revolve. Now, as I revolve that, what it's going to do is it's going to spin that triangle around three-dimensionally around that line of x is equal to 2. So if I look at that, I can click and drag to change the viewpoint, and I can see that this is a cone because we spun it and now has that circular bottom and it's got that triangular peak. We've created a cone out of this. But it didn't ask what solid it is, although that does help. It asked for, if we look back here, to find the vertical cross section. So a vertical cross section is going to take this solid and I want to cut it from top to bottom. Well, if I do that, all I'm going to see is the two-dimensional representation of what I see here. So if I look at the outline of this cone, I have a triangle. So in essence, if I come back here, if I look at the original triangle, looked something like this right here. And I revolved that around this line y or x is equal to 2. What I've done is I've reflected that over to this other side. So I had a distance originally here from 2 out to 8 of 6. So this distance was 6 right here. This new distance is also going to be a distance of 6. So that total bottom side now, if I just draw it by itself, has a distance of 12 along the bottom. But that height, originally we had a height of 6, that height's still going to be 6 tall. But this outer dimension here, that is what our cross section is going to look like. That cross section is going to be that red triangle spanning from all the way over here on the right to all the way over here on the left. So if I go back to this tool, one way I can see that is originally I just had this red triangle here. But if I want to see the other side of that vertical cross section, instead of revolving it, I can reflect it. And if I look closely, I can see that grayed out triangle is where we started, but then that reflection in red here shows me the rest of that vertical cross section. So let's take a look at another one. So what if I, instead of going about x equals 2, let's change this and say I want to take this shape and revolve around the line y is equal to 0. So now I want to take this red triangle and spin it around y equals 0, which is going to be your x-axis. So if I look at my original, I had a triangle. It started at 2, went out to 8, and up to 6. Looks something like this. And we want to spin it around this way. Well, two-dimensionally, if I spin this around, it's going to come down and look something like that. And this upper side here was at positive 6. So now down here, I'm going to be down at negative 6. Well, let's see that over here. So if I graph my original, that was our original triangle right there. So I want to come down here, click in this circle now because I have a y equals line. We said we wanted to go y equals 0. So I want to make sure that this number here is the one that I have as 0. And I'm going to revolve that. When I revolve that, it's going to give me my three-dimensional object. It's still a cone because we still spun it around and got the circle as the base, but now that cone is going out to the side. And if I want to see just the original triangle and its cross-section, vertical cross-section, I'm going to hit reflect, and I can see where that reflection would be so that I have that two-dimensional expanded triangle as my cross-section. So this entire triangle, the combination of the blue and the red, would be that vertical cross-section that we are looking at. Now, there could be times, let's come over here and say, I have a triangle that starts up here that's not touching the x-axis, but I still want to revolve around the line y equals 0. Well, when I reflect that, this distance here was a distance of 1, so that reflection better also be a distance of 1 away down here. So I'm going to have down 1 here, but then I have that same triangle just reflected on that bottom side. So we're not always going to have that perfect shape where it meets up, but we are going to have a reflection over whatever that reflection line or that revolution line is to give us that vertical cross section.